Hello children, let us see algebraic operations on complex numbers. We will see addition, subtraction, multiplication, division of complex numbers and their associated properties. First, addition. Suppose z1 and z2 are two complex numbers such that z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. So z1 plus z2 is equal to a1 plus a2 plus I into b1 plus b2. This is real part and this is imaginary part. It is clear from here that real of z1 plus z2 is equal to real of z1 plus real of z2 and imaginary of z1 plus z2 is equal to imaginary of z1 plus imaginary of z2. Let us see properties of addition of complex numbers as we have been doing in our previous classes for other types of numbers in number systems. First property, closure property. If z1 and z2 are two complex numbers, then z1 plus z2 will also be a complex number. It is clear from here. Second property, commutative property. Whether you add z2 to z1 or z1 to z2, result will be the same. Third property, associative property. Suppose z1, z2 and z3 are three complex numbers, then they can be added together in any order. First add z1 to z2 and the result to z3, or first add z2 to z3 and the result to z1. Outcome will be the same. Fourth property, additive identity. Complex number 0 is called additive identity for complex numbers. Complex number 0 means its real as well as imaginary part is 0. When you add 0 to any complex number, you will get the same complex number. Fifth property, additive inverse. If a complex number is z, then minus z is called as its additive inverse. Or if a complex number is minus z, then plus z is called as its additive inverse, such that when they are added together, result is 0. Now let us see subtraction of one complex number from the other. Suppose z1 and z2 are two complex numbers, such that z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. So minus z2 is equal to minus a2 minus ib2. z1 minus z2 can be written as z1 plus in bracket minus z2. Now we will add these two. So it becomes a1 plus ib1 plus in bracket minus a2 minus ib2. So it can be simplified as a1 minus a2 plus I into b1 minus b2. This is real part and this is imaginary part. It is clear from here that real of z1 minus z2 is equal to real of z1 minus real of z2 and imaginary of z1 minus z2 is equal to imaginary of z1 minus imaginary of z2. Third operation is multiplication of complex numbers. Suppose z1 and z2 are two complex numbers such that z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. So z1 z2 is equal to a1 plus ib1 into a2 plus ib2. This can be simplified as a1 a2 minus b1 b2 plus I into a1 b2 plus a2 b1. This is real part and this is imaginary part. So we can write real of z1 z2 is equal to real z1 into real z2 minus imaginary z1 into imaginary z2. And imaginary z1 z2 is equal to real z1 into imaginary z2 plus real z2 into imaginary z1. Now let us see properties of multiplication of complex numbers. First property is closure property. If z1 and z2 are two complex numbers, then z1 into z2 is also a complex number. We have seen it here. Second property, commutative property. Whether you multiply z2 to z1 or z1 to z2, result will be the same. Third property, associative property. Suppose z1, z2 and z3 are three complex numbers, then they can be multiplied together in any order. First you multiply z1 and z2 and the result to z3, or first you multiply z2 and z3 and the result to z1. Outcome will be the same. Fourth property, multiplicative identity. Complex number 1 is multiplicative identity of complex numbers. 1 can be written as 1 plus 0i, which is purely real. When 1 is multiplied with any complex number, result is same complex number. Fifth property, multiplicative inverse. Multiplicative inverse of a complex number z is equal to 1 by z. so that when they are multiplied together, result is 1. It is denoted by Z inverse or 1 by Z. Sixth property is distributive property. Suppose Z1, Z2 and Z3 are 3 complex numbers. Then Z1 into in bracket Z2 plus Z3 is equal to Z1 Z2 plus Z1 Z3. This is called distribution over addition of complex numbers. Fourth operation, it is division. The division of a complex number Z1 by another non-zero complex number Z2 is defined as the multiplication of Z1 by the multiplicative inverse of Z2, and it is denoted by Z1 by Z2. So by definition, Z1 by Z2 is equal to Z1 Z2 inverse or Z1 into 1 by Z2. In next video, we will see conjugate, modulus, argument and their properties. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.